Okay, science time. Today in science time, physical science time even, we're talking about science. And we're talking about measurements. Science and measurements. You already know about science, like the principles of science, and we're going to cover that pretty briefly. There are also, there are probably good YouTube videos you could watch of real people talking about this, but if you want to watch me specifically talk about it, there are 2 other videos I've made just this year about the scientific method that you could watch also. So, in fact, I think even that you were forced to watch one of those videos, right? That's the one video where you were forced to sit down and look at a YouTube video, take notes over it, and were graded. So you already have watched a video about the scientific method. Let's just review real quick. The scientific method is the way that we do science, the way that we apply science to the world. Remember, science is both a process and a body of knowledge. It's not, we had said before, it's not just a body of knowledge. Science is not just about what shape of leaf is this, or which planets are in order of the solar system, or what are the kingdoms of life. Those things are part of science, and they're the vocabulary we have to have in order to effectively communicate in science. But it's also a method. It's a way of looking at the world. It's a way of looking at the world, and that entails, to me, at least 3 steps. Usually, there's some kind of observation or question. Usually, there's some kind of investigation. And then in order for it to be a good science, there needs to be communication. Just like in order for it to be a good relationship with your little boyfriend or whatever, it needs to be good communication. The observation or the question can be based on any natural phenomenon. What's a phenomenon?
Something that takes place.
Yeah, it's an event or an idea in science. But it has to be observable. Ghosts, is that observable? No, it isn't a phenomenon. It's not a natural phenomenon. Maybe, Gunnar. I'm not saying, Gunnar, that there is no such thing as ghosts. I'm saying that would be a supernatural phenomenon. That not all observers can observe ghosts at the same time. That's been shown time and time and true. Someone might say, oh, the Brick 17 at Fort Robinson is haunted. If you go in there, you'll see a ghost. But not everyone that goes in there sees a ghost. And even if you look in the same spot, whereas if someone says there's a sunflower by the side of the road, anyone who comes, not a blind person, but they could feel it, anyone who comes could observe a sunflower in that location. That is not true of the ghost, and so that's not a natural phenomenon. So those are things that are outside of science. Does that mean they don't exist? No, I'm not saying they don't exist. I'm just saying they're outside of science, so we don't worry about them in science. So it has to be a natural phenomenon, and then we have an observation or a question based on that. The investigation, what are some things that the investigation can be? Okay, I think you're getting at dissection. Yeah, okay, so there could be a dissection. That would be one kind of investigation. What's another one? No, what? I'm thinking of things like research. Like, remember we had talked about if you want, or you watched in your video, if you wanted to find out what kind of snake that was, you would probably research it. You could type it into Google. That would be research. But you can also, be quiet, please. You can also perform an experiment. That's asking a question, but that's not an investigation. Maybe it leads to that. But if you ask your question of someone who knows more than you, then that's part of the investigation. Anyway, you could also do an experiment. If you have 3 kinds of cat food and you want to see which one makes your cat lose weight, you could try all of them for a week. That would be a type of experiment. So this could be an experiment. It could be research. What about communication? What are some ways we communicate in science? When you think about professional scientists, how is that communication affected in sciance? Like, no, they call people on the phone. They call everyone in the world on the phone. And they say, "Hey, I just found out this new thing about the gallbladder." No, how is scientific communication usually? No, come on, guys. Yeah, published papers. Shh, stop talking. Published scientific papers. If you're in this class, how will you communicate your findings that you do in the laboratory? No, you aren't going to publish it. It's just going to be your lab document. How will you tell, if you just identified that kind of snake using Google and Dalton was curious, how would you tell him? You're just going to speak it to him. That's all kinds of communication. Speak it. So here, what I'm getting at here is that the scientific method, your book goes through a specific scientific method here on page 8 that has, come here, look there. You can freeze it if you want. This is not something I cared very deeply about. This one happens to have 6 steps and then a 7th step that like forks off. The one on the back of the door to Mr. O's room has 5 steps, I think. You can find them that have 4 steps. This one has 3 steps. What does that tell you if all the scientific methods that we're thinking about have different numbers of steps? That's not real, and we should all just forego it altogether. We should just pretend it doesn't exist. No. What is it saying at all? It's saying that this is not itself a phenomenon. This is not something that everyone can observe. This is just every situation has its own specific method that you should probably follow to get the information that you need to make a conclusion. So what I'm getting at, to put it more briefly, is that the scientific method is not set in stone. The scientific method is not the 10 Commandments. We go through them in whatever order suits the situation best. The book also, this is from your vocab, so we're not going to talk about them, but you need to know the different kinds of variables, what a hypothesis is, the difference between a hypothesis and a theory, scientific law. All those things are vocab words. As long as you have done your vocab and you understand them, that should be fine. Now we're going to get to the main thing I want to talk about today, which is the SI. So please write those letters down. Capital S, capital I. We're about to find out, I bet. The SI stands for, it's in French, it stands for the Système. I can never remember which way these accents go. I think it's this way. Système I'm going to spell it right. National d'Unité. You don't have to know this because this is not French class, but this is in English. The translation is the International System of Units. The reason we have to know the French is because the abbreviation is SI. No matter where we are, we abbreviate it SI. Even though in English we say it as the International System of Units, we still abbreviate it SI because it is French. The Système International d'Unité. International System of Units. And this is based off of the old metric system. So we can call this this is kind of like the new metric system. In the Système International des Unités, there are 7 base units. Base units, I want you to write them down. The base units and then their abbreviation. And I'm going to make this a better, stop talking please. I'm going to make this a better little table for you. There are 7 base units. There we go. Please stop talking. We're going to have their little, so this is going to be their name over here. 1, 2, 3, 4, 5, 6. Okay. And I'm going to tell what they measure over here. The kilogram. Kilogram, abbreviated kg, measures what? What physical quantity of the universe? Do you know? You really probably should know. I'm disappointed. What physical quantity of the universe does the kilogram measure? Gas. No. What property of matter does a kilogram measure? No. Mass. That was disappointing. Okay. The next one we have, let's do this one next. Candela, abbreviated capital C, lowercase d, measures luminous intensity. What does the words luminous intensity mean? Luminous intensity, what might that mean? The amount of what? Light. The amount of light. It's a base unit. The Kelvin, abbreviated just K. Listen, this one's kind of important, and it should be a lowercase k. It's not degrees K. We have degrees Fahrenheit and degrees Celsius to measure this quantity, but this is not degrees K. It's just K, Kelvin. What does that measure? Temperature. Good job. Good. Temperature. Hey, I love this one. This is the mole, and its abbreviation is MOL. The word is MOLE, and the abbreviation is just MOL, and this measures amount of matter. Amount of matter. The meter, abbreviated lowercase m, measures, what does a meter measure? Distance. What's the second one, Candela? It's also in a chart on your book. It's also in a chart in your book. Electrical current. Oops. Ran out of room. Is measured. Oops, I put it in the wrong dang box. No wonder. I think it will. You're thinking the wrong thing. An ampere, which you cowboys abbreviate amp, which is capital A, measures electrical current. See, Gunnar, this is going in this box, which it will fit in. And then what is the last one? I'm trying to do these without having to think of it, or without having to look at the book. You have the chart there. Give me a hint. What does? The unit itself? Or the thing it measures? Okay, there is an A in it. Thanks, Gunnar. Someone give me another hint. I'm really trying hard to remember this. No. Why is no one listening to me ever? Someone help me figure out what the last base unit is. I can't. It's in the book. Give me a hint, Shylin. Just a hint. The word one is my hint. Oh, of course. Yeah. That makes me feel stupid. Seconds, abbreviated S, measures time. Okay, now listen, these are the base units. Does that mean, are these all the units in the world? No, of course not. Of course not. Is seconds a convenient way to measure time? Well, on Mario Kart it is. But is seconds always a convenient way to measure time? No. How many seconds old are you? You don't know. That's not a useful way to measure time, usually. But all of these, doing some math, if we add these with math, we shove math in here, we get two things. We get derived units, and we get prefixed units. Prefixed. Okay. Okay. The derived units are something like meters per second is a derived unit for speed. Look, it's made out of base units. The meter is a base unit, and the second is a base unit. But now this is a different unit. It measures speed. That's an example of a derived unit. Another example of a derived unit is a joule, which is a kilogram times a meter squared per a second squared, which measures energy. And these are all based on derived units. We just have another name. So where we have meters divided by seconds gives us speed. Look, we did math to two of them. Meters divided by second gives us speed. We can also sometimes have a different name for it. So kilograms times meter squared divided by second squared, that we name that a joule, and that measures energy. So those are the derived units. Yes, Peyton. Amount of matter. And then we also have prefix units. Add a prefix to one of these to make a new unit. Quickly, please.
A prefix and a suffix?
Yeah. What's one of, like, okay, can we add some kind of prefix to meter to make it mean different from just 1 meter? No. Like
Kilometer?
There we go. Thank you, Gabriel. God bless you, Gabe. A kilometer is 1,000 meters. So it's still the base unit. It's still a meter, the base unit. It's just now that number is worth 1,000 regular meters. Let's go over the prefixes real quick. The prefixes real quick are, and these are going to be the important ones, that you must have these memorized. You need to know these, okay? Milli, which means 1/1000th.
You could also add millimeter.
Yes, you could. That's what I just wrote down.
Oh.
Centa means 1/100th. Deci means 1/10th. Kilo, Kilo, I'm going to write it again. Okay. Kilo means 1,000 times. Mega means 1,000,000 times. And giga means 1,000,000,000 times. There are different ones in your book too, I think. Nope. Oh, they also have micro and nano. We should probably do these. They also have their own little symbols at the beginning. Lowercase m is milli. So what would be the abbreviation for millimeter? Shh, be quiet, please. What would be the abbreviation for millimeter? mm, yeah, lowercase m, lowercase m. Centa is lowercase c. Deci is lowercase d. Kilo is lowercase k. That should have been a lowercase k. Mega is capital M, and giga is capital G. The two others that you need to know, I should just tack them onto the bottom here, sorry, even though they really should be at the top. Okay, I'm going to put them at the top. Sorry. Are, it's all right still. Let's start from the lowest one, which is nano, which is lowercase n, and that one is 1/1,000,000th. And then micro, which I'm going to talk about that in a second, but micro is 1/1,000,000th. This little thing here is the lowercase Greek letter mu, which looks kind of like that. Nope, I put the tail on the wrong side, sorry. There we go. Lowercase Greek letter mu, which is like a U with a big old tail on the end of it.
What was the last prefix?
Giga or micro? The last one I said was micro. The last one that was on the list is giga. These are in order from smallest to largest. Let's use meter as an example. What's something that we might measure with a nanometer? I'll tell you, a nanometer is usually used for things like molecules, or maybe the insides of a cell, like very, very, very small stuff. Micrometer is how I pronounce this. A micrometer could be used to measure slightly larger things, like maybe cells themselves, not the stuff inside a cell, or like the width of a hair could be measured in several tens or hundreds of micrometers. A millimeter, what would you measure in millimeters? What's something that you know that we measure in millimeters? Fate's forehead. We could. That wouldn't be a very good one. Your pencil lead is measured in millimeters. The agreed upon way to measure calibers of ammunition that isn't American is in millimeters, like 9mm rounds. I'm trying to think of what else that we. So I have several, like what we call metric sockets and metric wrenches use millimeters as a measurement. What about centimeters? What do we measure centimeters? Also Fate's forehead. That would be a good one for Fate's forehead, actually. Usually people's heights is expressed in the metric or in the SI in regular base meters. Oh, by the way, base goes. Oops, sorry. The base unit goes. What's the base unit worth? If deci is worth. What's the base unit? What would I call the base unit here? Well, guess what? Base units are this. So the meter in this case is just 1. 1 meter is 1 meter. There's no prefix on it. The base unit would be shoved in between these two on this chart. Decimeters, we don't use this one a super lot, but it's kind of like how we would use feet in the English system. Maybe it's more prevalent in places where they actually use a system on a daily basis. Kilometers we use to measure distances, like especially land distances. Megameter would be like the distance between here and the moon we would measure in megameters. And then gigameters would be like the distance between here and the sun. Or further, even, several times further. Do you kind of get the gist of the SI at least? The book goes on to talk about how to measure volume and density, but do you know how to measure volume or do you know how to find volume and density? I'm going to write them over here. But we just did a whole lab about finding volume. Tell me the equation for volume. Write that down, please. Tell me how to find the measurement of density. Rho equals mass. Your book uses capital D. At this stage, I'm fine with that. We will use rho when you get to chemistry and physics, so you might as well start using it now. Rho equals mass divided by volume. Density equals mass divided by volume. I'm gonna put a rectangle around some things, not everything, that you need to have memorized for your test. For one thing, the vocabulary. If you don't know the vocabulary, you might as well just eat your test because you're not gonna get a good grade on it. So know the vocab. Look, you need to know these two equations. When I say know, how do you know an equation? No, answer me no, we can't just figure it out. What do you need to do to know an equation? What? You need to memorize these equations. These need to be memorized. You need to know when to use them. You need to know not all of the base units, but you need to know the kilogram, the Kelvin, the meter, and seconds are the base units you need to know. You must know all of the prefixes. You must know all of the prefixes. Questions? Questions?